In this devlog, I will demonstrate all the new features that I have added since the previous one. So here's the list. The very first feature that I worked on is the entity component system, or ECS for short. I implemented version 1.0 of this feature. The second is the line renderer. Third is the physics engine integration. Fourth is this material editor, and then some usability improvements in the level editor that I will show you towards the end. So let's start with the entity component system. Let me give you a brief introduction as to what this is. ECS, or entity component system, is a design pattern that is used in modern game engines to simulate very large number of entities. It can handle around hundreds of thousands of entities simultaneously. This design pattern achieves this with the help of tight memory alignment and effective use of multi-threading through job system. What this design pattern does is that it decouples the data and the functionality and separates them. The system part of it handles all the functionality, and the component holds in all the data, and entities are just IDs that are used to identify the which set of components an entity possesses. So it is used to index into the components, and through the use of queries, the systems will perform a certain type of calculation on a certain group of entities. So this is a very powerful system. In my engine, for now, I just implemented its version 1, and this version of ECS just takes into consideration the API design. That was the core focus of this. So let me just show you how this currently works. So we simply create an entity. We can just give it a name that will show up in the scene graph. We create a component, assign that component to this entity. We can create multiple components and then connect it with this entity, and then we feed this entity into the entity manager, which in turn hands over this entity to all the systems that need it. So this is the basics of ECS. It establishes the standard on how to use the engine to write a code. So the next feature is the line renderer. As you can see, I created this grid, this cube outline that has been scaled, as well as this yellow line with the line rendering system. And another feature of this line renderer is that it's dynamic, so you can modify the lines update at runtime. There are many benefits to the line rendering, specifically when debugging and also identifying things in the editor. So line rendering can come in handy when showing the physics surface colliders, these editor grids, and ray casting. Also, the ray, this yellow line represents a ray that will feed into the physics engine. So now I will demonstrate the integration of physics engine. The engine that I went with is called Jolt Physics. I went with this for a couple of reasons. One is that it is open source. The other, and most importantly, is that it is a deterministic physics engine. Deterministic physics simulation or a physics engine has many benefits, specifically in the multiplayer context, such that you can simulate or you can replicate a simulation on multiple clients, provided that the order of inputs match. So as you can understand that this can become greatly beneficial for a multiplayer scenario. So with this physics engine, for now, for this current implementation, I focused on three things. One is the rigid body simulation, the other is the collision detection and the response, the third is ray casting, uh, which is what this yellow line represents. So I'm going to start the simulation. This ball is going to fall down on this surface that will perform a collision check and stop this ball from falling further. So this will act as a surface, and this yellow line will perform, as soon as this ball reaches this line, it will perform a ray intersection test. So let's run the simulation. As you can see, this ball fell to the floor, and also if I zoom in on this line, you can see that there is a pink cube representing the intersection point with this physics body. Now you may notice that this is not accurately on the surface of the sphere. The reason is that I tested the ray casting with the broad phase of the physics engine. A physics engine has two phases, a broad phase and a narrow phase. In broad phase, all the intersection tests are done against axis aligned bounding boxes. What it does, this is an optimization technique. What it does is that there is an invisible box that surrounds any arbitrary shape, and that box can only be seen by the physics engine. So once in the broad phase, all the bodies that require further computation are identified through this method, through the ray and axis aligned bounding box intersection tests. It then sends those entities or those physics bodies to the narrow phase, where more accurate computations are performed to reflect the shape of the geometry, or to be exact, the shape of the collider that is placed on that geometry. So this is how every physics engine usually works. There's a broad phase and then there's a narrow phase, and this optimizes or reduces the number of computations that need to be performed within a simulation. The next feature that I'll show you is the material editor. Now previously, so let's select this floor, and we can see that material 2 is selected from the asset browser. I also added support for textures, and I can see and visualize that which texture is this string representing. So let's assign a different material to this surface. Now I can select this material in the material editor and apply a different texture on it. Besides that, I can also tile these textures. So I can do the texture tiling. Let's do it by hand for more accuracy. And also we can offset the texture. So this is the material editor. It just improves the level editing user experience even more. Continuing with the theme of user experience improvements, another feature is that I can now duplicate any shape that I customized by creating from the shape editor. So this is a cube that I modified into this tall beam, and what I can do is I can duplicate this. So as you can see that this feature may look trivial, but it has a huge impact when you have to design a level. Now lastly, it's a minor feature, but this also adds up to the user experience improvement, and that is that previously, in order to save a scene that has not been saved before, I had to click this button, save scene as, and when I did so, it opened up a dialog box where I can type the name of the scene and save. And if we clicked the save scene button, it would do nothing if the scene was not previously saved. However, if the scene was already saved and then you perform some modifications and then click this save scene button, it would save fine without showing any dialog box. But let's say you have not saved the scene, and when you click this save scene button, it opens up the dialog box. Now, this is something minor, but everything counts. All of these features just add up to the user experience for this engine. So that will be it for this Devlog. See you in the next one. Thank you.